Hey everyone, welcome back to DreamSpace TV here in One Microsoft Place in Dublin. Thanks for joining us again. How about we get stuck into today's episode?
So today we're going to recap over the extension challenge we had in the last episode. And then we're going to discuss AI for Earth. And finally, we're going to learn all about how the microbit can use radio. We're also going to focus in on the Sustainable Development Goals again. So in particular, we're going to look at the goals 13, 14 and 15. Amanda, would you mind reading out which goals they are?
Yeah, no worries. Again, I have it here because I don't expect anyone to remember these off by heart. So 13 is climate action, 14 is life below water, and 15 is life on land.
Great. And maybe I'm going to pick out 13 in particular because it's linked to our Do Your Bit challenge.
Yeah, great idea.
So it's quite important. So let's get started. So I'm going to open up my microbit platform and I've got the solution to our extension challenge. So in your extension challenge, we asked you to create 5 unique conditions for your well-being picker. And as you can notice, we had already 3 done the last day. So we extended a little bit further. So at the start, we had to set it to pick between 1 and 5. So we had to change that. And then as you move down, you might notice that we had to ensure that our variable was equal to one of those conditions. So in the first case, 1, second case, 2, the third case, 3, 4. However, you might notice the 5th one actually doesn't have that comparison block. And the reason why that is, I'm going to make it a little bit smaller, even though we still mightn't see it all, is that it's the only other option. If our program doesn't pick a 1, 2, 3 or 4, it has to pick a 5 because it has no other option. So we don't need that comparison block in the case of the last condition.
Yeah, and that's going to be something you come across all the time with the else piece. Like
Exactly.
The else is always used at the very end of your conditions to say if it's none of that stuff exactly, it has to be this one. Yeah.
Great. So that's just one solution or one way in which you could have come up with a 5 unique condition well-being picker.
Yeah. And
Amanda,
actually, sorry Niamh, but I was just thinking there, I would love to see, so make sure to share with us. You might have done different animations for breathing in and out. You might have done different like pause times, you know, the way we had 2 seconds in and 2 seconds out. So please share with us. We'd love to see like how you got on with that and what you did in your schools. So let us know.
Great. And another part of your extension challenge was to look at AI and think about how you could incorporate AI into your wellbeing picker to maybe encourage someone to use it more. So I know this is something we discussed.
Yeah, it was. We were thinking, well, how about if I had this microbit as a user and if there was some way to track the data, because remember data was key for AI, for how I was using this. So for example, if I had the microbit and I shook it, and a certain like breathe in out came on and I didn't really like that one, maybe I'd shake it again to move on quickly because I didn't like that one. AI systems would pick up on that. They would pick up on your behavior as a user and as a result maybe customize it a bit more to always show you the types of animations you want. So it's learning, remember that was a key part of AI, it's learning from your behavior and it's adjusting its program as it goes as a result. So that was just again one example of something we thought that kind of maybe some AI systems might do. But you, again, might have had different ones. So again, share them with us if you did. So we're going to stick with AI and we're going to look at AI for Earth. Now remember, that was one of our AI for Good pillars that we introduced last week. And it's exactly what it sounds like. It's looking at things like sustainability and conservation. There's an amazing organisation that we work with called Wild Me. So let's hear from them.
There are an estimated 90,000 threatened species across the globe. To understand what puts a species at risk, we need to know where are they born, how many survive, where do they go, how far do they go, how do they respond to different conditions. We really do need to learn about every individual animal.
At Wildbook, we are using an algorithm to digitally tag individual animals, much like a human fingerprint.
At Wildbook, anyone with a camera can become a citizen scientist, and anyone uploading animal photos or videos to social media directly contributes to conservation. Microsoft AI gives us the building blocks to analyze public streams of photos and videos and identify individual animals in an instant.
So this is a new whale shark for science.
Yes, and we named it Wilma.
Wilma the whale shark.
AI can determine location, date of sighting, migration patterns, and even an animal's social group. And even if the information is not available, an intelligent agent can contact the content's owner and ask for the missing detail. Microsoft's AI for Good initiative gives us the technology to create a comprehensive view of the planet's biodiversity. In the last 10 years, we've identified 10 times more whale sharks than ever recorded in human history. By leveraging citizen scientists and bringing them together with researchers, we can form conservation policies. Microsoft AI will help us accelerate our work by empowering people to take action. What we get back is, wow, this is amazing.
Okay, so WildMe is an organisation that we really love to talk about in DreamSpace because they help protect endangered species. What I want us to do is just take a second to think about the formula behind any AI and think about how this works specifically with WildMe. So remember, this was our formula. I just wrote it up here from the last episode: data, algorithms, and machine learning. So let's start with data when it comes to WildMe. The cool thing about WildMe is that any citizen can contribute to the data, because I could be on safari somewhere, so could you, Niamh?
I've contributed to it before.
Oh, well, there you go, there you go. And we could be going around, we could see an animal, we could take a photo, and we could upload it for the WildMe system. And then they can use that data to help identify not only just the animal, but the breed of animal too. And the reason they can do that is simply because of these algorithms they've developed and how the machine has learned to work with those algorithms and with those photos. So it's pretty cool. So they're able also to track the movement of animals. And that's something that we're going to specifically challenge ourselves to think about in today's episode, isn't it?
Yeah, so today we're going to look at how the microbit uses radio. So the microbit has an inbuilt Bluetooth antenna, which can send and receive messages from one microbit to another microbit.
Yeah.
So before we do that, in its basic form, that would be like using a walkie-talkie.
Yeah, exactly. That's the way I always think about it anyway.
So before we get started, you might think about or jot down the steps you might use to communicate with somebody else using a walkie-talkie.
Right, so you might have had a number of steps there for how we would use a walkie-talkie. So we're going to break it down, we think, into 3 steps, all right? It might not be the exact same as us, so don't worry whatever you have, but let's cross-check it off what we have here. So step 1, Niamh, call it out to me.
Well, I think one of the most important things to do would be tune into the correct channel.
Yeah, absolutely. So first of all, we're going to turn it on, and then we're going to...
That would be a good start to turn it on.
You're right. And tune it. Here we go. Tune to the channel. Okay, so within the microbit, it's going to be something similar. Obviously, we need to power the microbit up, and then we need to get it to the right channel. And in the case of the microbit, it's called a group, isn't it? Like in the category. So just to bear that in mind, you might not see the word channel, you'll see the word group, but it's the exact same idea. All right, so that if Niamh is on channel 1, I have to be on channel 1 if we want to communicate. Simple as that. I suppose step 2 then would be that if I had a walkie-talkie, I would then, and we know we're on the same channel, I would hit the button and I would start to speak. So we're going to just say hit a button, and we know the microbit has buttons, and I would speak. Now, the new microbit actually has a microphone, but a lot of the other versions don't. So we just say when we hit the button, we might send a message of some sort. We can decide that when we're in our program in a second, but that's all good. Okay, the idea is we have an input, and then something will happen as a result after that input. Yeah. All right, and then 3, Niamh.
So once you've hit your button, I need to be able to receive it so I can hear your message.
Exactly. So we need to receive it. And that might sound really obvious, by the way, like you're thinking, well, of course it will receive it. But remember, with code, we have to be really specific. So we actually need to tell the microbit what to do when it receives it. And in the case of the walkie-talkie, yes, Niamh would hear my message. But with the microbit, remember, we're probably going to just have to display it in some way. So we're going to receive it, and we're going to show the message at the end. Okay, so these 3 steps will be important, and keep these in mind now when we get going on our coding. So now will be a good time to pause and log in on your browser of choice to www.makecode.microbit.com. DreamSpace.org.
And that will take us to the home page. However, we're not going to do what we done in the last episode and click on new project straight away. We're going to go down to the radio game section and we're going to click on multi-editors and show instructions.
Yeah, which is really cool. This is actually a new feature of the Make Code Microbit app. And you didn't used to be able to do this. You used to have to go new project and try and look at them side by side, and it used to be really confusing. So this is a much clearer way of understanding how radio works.
So we've got 2 microbits here, and we're going to send and receive messages through these 2 microbits. So today's specific focus is to look at our global goal number 13 in particular, climate action.
Yeah.
And what we're going to try and create is a polar bear tracking system, whereby 1 microbit is going to be attached to our polar bear, and it'll send an alert or send a message if the polar bear is moving, and the other is going to be attached or with the ranger, and hypothetically I'm going to pretend I'm the ranger receiving this information.
Yeah,
so the first thing I'm going to do is create my new project, and I'm going to call this one my polar bear.
Do you want me to write this in?
Yeah, if you don't mind.
Yeah.
So,
oh, sorry, I'm in the wrong one.
No problem. So on the left-hand side, we're going to have our polar bear's microbit, and on the right-hand side, we're going to have our ranger's microbit. Okay, so this is where we're going to receive our data. So now, let's get started. Let's think back to the steps that you went over when we were thinking and talking about walkie-talkies. So the first thing we needed to do was we needed to tune both radios into the same channel or same group.
Yeah.
So I'm going to click in on radio, and as I say, I'm going to set the radio group to a specific number. So I'm going to drag it out and bring it into on start because I want that to automatically happen. And when I'm thinking about setting my radio group, I'm going to set it to group number 13 because we're focusing in on Sustainable Development Goal 13.
Good shout. I wasn't sure what number.
Great. And now we're going to set the polar bear's radio group so that it's tuned into the same channel. Okay,
Perfect.
So Amanda, if you wouldn't mind setting that to 13 as well,
Yeah.
so that they're both on the same channel. So now I'm going to use the forever block for my polar bear. I'm going to drag it down here. And why I'm going to use the forever block, I know Amanda mentioned earlier that we might use a button, but the polar bear can't actually press a button.
Yeah.
So
It's not going to be like, I'm on the move. Like,
exactly.
yeah.
And we want it to be a continuous process. So we wanted to read this data forever.
Yeah.
So what we're going to do now is we're going to set the conditions necessary for our polar bear. And where we're going to go is into our logic and bring out our if true then else block. And Amanda, how many different maybe conditions do we need?
Yeah, so what we're going to look at here is the acceleration of the polar bear, because obviously we're looking at movement. And the way it works with the microbit is the microbit can either accelerate one way or the other. And we're going to be, again, it's a little bit mathsy, we're going to look at the x-axis. So it can either go in a positive direction on the x-axis or a negative direction on the x-axis. So that's 2 anyway.
Okay.
But then it also maybe doesn't move at all. So there's your third.
Third option.
Yeah.
Okay, so it can move both left and right, and it can also not move at all.
Exactly. Yeah.
Okay, so now we have to look at our statement here, if true then, and we need to think about the comparison. So if acceleration is maybe greater than 0,
Yeah,
so
perfect.
it would let us know that the polar bear is on the move.
Yeah.
So I'm going to go in and get my comparison block, and I'm going to drag it out and connect it into where true is, and I'm going to look for my inbuilt sensor acceleration, which is here.
Yeah.
I'm
And
gonna
you can
connect
see
it
there,
in.
Niamh, it's actually automatically says X. So there is obviously other axes that they could look at, but X is what we're talking about here. It's moving across. Yeah.
Exactly. And I'm going to change it to less than 0, which means the microbit will be moving one way.
Yeah, and it'd be minus, that they would all be the minus numbers when it tilts. Yeah.
Exactly. So I want to let our ranger know that the polar bear is on the move if it is less than 0. So I'm going to send a string. But I have to be careful here now. And I have to make sure that I send a radio string, because that's really important. And just looking here, we can also send numbers and values. So that might come into play with the extension challenge. So that's just a little hint there.
Yeah.
Okay, so I'm going to radio send string. And Amanda, would you type in maybe M for moving so that it's really clear to the ranger that the polar bear is on the move?
Yeah.
Great. Okay, so now I'm going to do the exact same thing for our second condition, because that's if the microbit is tilted the other way, in the positive numbers.
Yeah.
So I'm going to copy this or duplicate it, and I'm going to bring it in here with my connector. And again, I need to change it to if it is greater than 0 this time, because we're talking about the positive numbers. And similarly, we want to send the same radio string, because this will mean that the polar bear is still on the move.
Yeah, exactly. So this time, as you said, it's going plus, plus, plus in one direction.
Exactly. So we've got our 2 conditions for if the polar bear is moving. Now we need to focus on what happens if the polar bear actually isn't moving, and what notification we might send to the ranger to let the ranger know that the polar bear is actually stationary.
Yeah. So I suppose it's useful here just to think, well, if it's not greater than 0, and if it's not less than 0, what is left for else? Well, 0. Equal to 0 is what's left. And again, that might be important for your extension challenge to know and to remember that.
So we don't really need a comparison block here, because we've set out the conditions for the first 2 categories. So now we just need to set out our condition for the third, which is the only other option, is to be stationary. So I'm going to duplicate this, and what I'm going to do is I'm going to change the string that I send. So instead of sending an M, we might send an N for not moving.
Yeah.
Okay, so now we've our code or our program set up for the polar bear. So if the polar bear is moving, it's going to send an M, and if the polar bear is stationary, it's going to send an N to the ranger. However, looking at the ranger's microbit, the ranger has nothing to receive that information.
Yeah, so again, this is something we talked about that we could take for granted, that we just assume, oh, the microbit will know what to do. But actually, this has to be coded into the microbit to be told you need to receive something, and then what does it actually do when it receives it?
So I'm going to go into my radio section, and again, I'm going to look at what I've here. So I've on radio received string. I've got received number. So there's a couple of different things. Again, this might be useful in the extension challenge.
Yeah.
But I have sent a string.
Yeah.
Okay, and it's important to note that. So the polar bear's tracker or microbit is going to send a string. So we need to be able to receive a string as the ranger. Okay, so on radio received string, we wanted to show the received string. So we wanted to show the string that we've received. Okay, so let's test this out. So I'm going to click on here and here, and my microbit should come up. Okay, so now the polar bear is sending the string. However, the received string is hello. So let me have a look at my code here on my rangers. I have it programmed that when it receives the received string, to show the string hello. And that's not really what I wanted to do.
It needs to be able to adapt, doesn't it, really?
Exactly.
Yeah.
I wanted to adapt to show the received string. So I'm going to have to draw on my variable and connect it down so that it will show the string, the received string.
Yeah.
Okay,
Perfect.
so let me test that out again. And let me see now. Okay, so it's not moving at the minute. And let's see, it might take a minute to reload, and it's after showing M for moving.
Yeah, there's a bit of a lag there, but I think even if you hold the pen down slightly, you'll see it'll stay on. I think you actually got it on the right side there a second ago. Yeah, and it just as it's coming back. Yeah, so you can see that really clearly. Cool.
Great. So I'm going to leave that up for a moment. And now would be a good time to pause and finish your code for the initial stages of the polar bear tracker using radio. Now we're going to recap over what we wanted to cover in today's episode. So in today's episode, we wanted to recap over our extension challenge from the last episode, which we completed.
Yeah, I think hopefully everyone's okay on that. Yeah.
Exactly. We wanted to discuss AI for Earth, and we looked at wild me, which was really interesting.
Yeah.
And finally, we wanted to learn how to use radio using the microbit, which I hope everyone will be comfortable and able to send strings from now on. So I think, Amanda, now we could maybe explain the extension challenge for today's.
Yeah, definitely. So the extension challenge that we want you to try out is kind of related to alerting the ranger. So right now when the polar bear moves, the ranger will see a string, a letter like M or N. But how about we make it more obvious if the polar bear is moving or not moving, say with the music category. Now we haven't used the music category yet, but could be useful for you to play around with. Now a big hint we want to give you for this is, if you look in the radio section, you cannot send music. But what we could maybe be clever about is maybe we could send a number, and then using some conditions, we could receive those numbers as music. Now that's a big hint, but hopefully it's enough to get you going and see how you get on with that one.
Thanks for joining us today. We hope you learned a lot about the microbit, including radio. Good luck with your extension challenge. Until next time, bye.
See yous.